Hello everyone, welcome to my channel Learning Math with Shelly. This is the third video about the Pythagoras theorem, and before that I have described what a Pythagoras theorem in the first two videos and what is the meaning of hypotenuse, the terms related to Pythagoras theorem and some word problems. But now we will be discussing some more important word problems, which will be like a right angle triangle which is inside a cylinder, or there will be composite shapes which are made up of 2 or 3 right angle triangles, finding the side, and these will be the multi-step problems. Okay, so please discuss. I'm going to discuss these problems in detail. So if there will be any doubt, you can comment me. Please subscribe my channel so that you can watch all these upcoming videos as well. Okay, let's start the video now. So the question here is, find the length of the longest rod that will fit inside a cylinder of height 2.1 meter and with circular end surface of 1.2 meter diameter. Give your answer correct to one decimal place. Now here, this is not like a question where you have given a direct right angle triangle, but you have given a cylinder. They said find the length of the longest rod that will fit inside a cylinder. So as we are not able to see any triangle here at the moment, but whatever is given information, we will be just drawing that. So we have described, like we have given, there is a cylinder. So cylinder is a 3D shape, something like this. Its two faces are circular and one curved surface is there. They are saying the height of this cylinder is 2.1 centimeter. So here I am gonna write this is 2.1 meters. Okay, after that they are saying the longest rod that you can insert in it. Now when you have to keep the longest rod in it, this is a surface, like this is a vertical cylinder, so this will be like a horizontal surface. You can consider like you have a steel glass, that is a cylinder form. Okay, and if you look at the top, the circular area, it is a horizontal, and same is this case. And they are saying this cylinder circular end surface, it has diameter 1.2. so if I draw this as a circle, so you can consider this whole thing is 1.2 meters, and we have to keep the longest rod in it. Very important point, if you want to keep the longest rod in it, so you can start with one end of the circular face, and if you join it with the opposite end here on the bottom circular face, so this will be the longest face, because whenever you have a right angle triangle, hypotenuse is the longest side. So if you want to keep a rod and which should be the longest one, it should be like across the diagonal, or you can say across this way. Okay, so this is the height and this is the horizontal surface, and here the angle formed, that will be 90-degree angle. Okay, so I am considering this is the height, this is the one side, and there is an angle of 90-degree, and this side will be considered as the hypotenuse, and we have to find this length of the rod because this is going to be the longest. Now this length is given as 1.2 meters and this length is 2.1 meter. So let's say we have these points as A, B and C. So we have to find out AC, and AC is a side which is opposite to the 90-degree angle, so this is a hypotenuse. So AC square is equal to AB squared plus BC squared, and here you have to substitute the values. AB is 1.2 meter square plus BC, which is going to be 2.1 meter square, and we will add them up. And if we have to find out AC here, so AC is going to be the square root of the sum of the square of these two results. Okay, so in case if I calculate this value, so let me see what is it going to be. It is 1.22 is basic square is 1.44 and 2.1 square is 4.41. so we have to add them and we have to square root. So it is going to be 5 here, 8 and here 5. So it is going to be square root of 5.85, and that you can easily calculate. Okay, you will not leave it like this, but whatever is it, 5.85 square root. So whatever result you will get up to one decimal place, and you will put a meter unit. Our unit is very important. So these kind of questions are very important. Sometimes applying Pythagoras theorem here is super easy, but the only thing is you need to know that yes, we have to apply Pythagoras theorem. So these are the indirect questions. So therefore I request you all to watch the video at the very end of the video. Okay, now the second question I'm gonna deal with, this is the same diagram, it's drawn here. Now the second question, it is a multi-step word problem where we need to apply the Pythagoras theorem more than one time. Okay, so the question here is that let's see here, the question is, for the shape on the right, find the value of x and y as a fraction. So we have to find the value of this x. If you see, there are two right angle triangles here. If I name them, let's say this is A, this point is B, this is C, and this is D. For simplicity, I put these names. Now, these are the two triangles. One triangle is ABC and another triangle is BCD triangle. Now, the thing is, I need to find out x and I need to find out y. So first I will start with A, that is I have to find x. Now the most important thing is recognize where is the hypotenuse. Here is the 90-degree angle. The side opposite to that is the hypotenuse. So x is hypotenuse and I will apply the Pythagoras theorem. So x square is equal to 3 squared plus 4 squared. So x square is equal to 9 plus 16 and x will be equal to square root of 25, which is 5 centimeters. Here only plus sign we will be considering because it is representing the length. Now if I look at the second triangle, which is triangle BCD, I have to find out y, and this is the length which is opposite to the 90-degree angle. So this is our hypotenuse. In triangle BCD, y is representing the hypotenuse. So if I apply the rule Pythagoras theorem, so y square is equal to x square, because one side is x centimeter, plus 6 and 2/3 of square. So if I convert this into the improper fraction, so this will be 6 times 3 plus 2, that is 20. So it will be 20 divided by 3, the whole square. Now we know that x is 5, so 5 squared plus 400 divided by 9, and from here y square is equal to 25 plus 400 divided by 9. Now I have to add them because they said answer should be in fractions, so no need of using calculator over here. Make the denominators equal, so times by 9 here and divide by 9. So 9 times 25 is 225 plus 400, because now the bases are same. So I got it 625 by 9. Now this is y square, so y will be equal to square root of 625 over 9, which is 25 over 3 centimeters. So this is the answer, 25 over 3 centimeters. But because this is an improper fraction, so answer should be in the terms of mixed number. So it will be 8 wholes and 1/3 centimeters. I hope these two questions are clear. I will be making some more videos on the different types of questions where we can use this Pythagoras theorem. Like these in this video the questions were particularly based on like a right angle has to be formed inside a cylinder, or there will be composite shapes. Next questions will be based on like the kite shapes and the canals based questions where we apply the Pythagoras theorem many times. Alright, please keep watching my channel, keep subscribing, like, comment and share. Thank you.